students, my name is Prem Kumar. So today we are going to discuss infrared spectroscopy instrumentation part 1. Okay, in instrumentation, the following components are mainly used. The components are, first one is IR radiation source, second one is wavelength selector, that we can say monochromators, then sample holders or cells, then detectors and recorders. In today's lecture, we will discuss the first three components: IR radiation source, wavelength selectors, and different sample holders, and also the sample handling in IR spectroscopy we can discuss. So coming to IR radiation source, the following are used as sources for IR radiation. Those are Nondisclosure, the global source, incandescent wire source, that is nichrome wire. Then fourth one is mercury arc, finally carbon dioxide laser source. So they are the five sources frequently used for the IR radiation. So based upon the sample nature, the solvent nature, the other effects, means other parameters we can consider for the selection of these sources. So first one is Nondisclosure. Just go through the pictures. So the arrangement or the construction of the Nondisclosure, so we can see in the picture. It majorly consists of cylinder of rare earth oxides formed into a cylinder of diameter 1 to 2 millimeters, length approximately 20 millimeters. So diameter should be 1 to 2 millimeter, and the length of Nondisclosure, it should be 20 mm. So platinum discs are attached at the end of cylinder to permit electrical connection. They are heated to a temperature of 1200 to 2200 Kelvin, where the IR radiations are emitted. The platinum leads at the end of the cylinder permits the passage of electricity. Nondisclosures are fragile. They have a large negative temperature coefficient of electrical resistance and must be preheated to be conductive. Okay, before going to start the experiment by using IR spectroscopy, where the Nondisclosure is used as source, so in that cases we should preheat the Nondisclosure to elevate the proper temperature which we require, that is 1200 to 2200 Kelvin. So in that temperature only, so we should get the evaluation of IR radiation. The second one is the global source. So these global source are similar to the Nondisclosure. It is also made up of a cylinder, like the picture shows. Here material used for the global source is silicon carbide. The length should be 50 millimeter and diameter should be 5 millimeter. It has a positive temperature coefficient of electrical resistance. So where Nondisclosure having the negative temperature coefficient. At low temperature, they provide low resistance to flow current, and as a cylinder gets heated, resistance increases, allowing conduction of current. So if there is no change in resistance, so we cannot get the evolution of IR radiation. To that, so resistance changes may be occur to give conduction of current. To avoid excessive heating, water cooling is necessary. At high temperature, source emits IR radiation. So similar to Nondisclosure, here also we use higher temperature to emit the IR radiation. The third one, incandescent wire source. Just go through the picture. Okay, so it should also called as nichrome wire. The cylinder in the above source is tightly wound by a spiral wire of nichrome or rhodium. It is electrically heated at 1100 Kelvin. So temperature for this source should be less compared to the first two sources. Whereas fourth one is mercury arc. Just to go to the picture, the quartz jacketed tube mercury vapors are present in the quartz jacketed tube. So electricity passes through the mercury vapors, which provides the radiation, evolution of radiation. Finally, fifth one is carbon dioxide laser source. It's mainly used for the detection of pollutants in air. So means the specific reason or specific cases, so we can use carbon dioxide laser sources. The second one is wavelength selectors. Okay, these wavelength selectors mainly gives the proper band of wavelengths. So output from a wavelength selector is a band of wavelengths. So here we have two types of wavelength selectors, that is filters and monochromators. So filters are the means oldest wavelength selectors. So these filters are very simple. They are sheets of plastic or glass that simply absorb wavelengths other than those required for the analysis. Generally, the range of wavelengths are allowed by a filter is relatively wide. So for example, if you need a proper wavelength, that is 257 nanometers for example, so these filters only allows this wavelength to output. Okay, means from the filter the light should be passes through the detectors or sample holders. So which we require, so that wavelength should be passed through the sample holders. So remaining wavelengths, whatever the polychromatic light contains, so that should be absorbed by the filters and gives only the required wavelength which is used for the analysis should be passed through the sample holders. Then second one is monochromator. These monochromators are far more complicated and comprise a series of optic inside a light proof box which has entry and exit states which allows the radiation of wavelengths in a narrow range of wavelengths out. So the monochromators are having the following parameters, the following components, whatever you can say. So that is entrance slit, collimating lens or mirror, then depression element, then focusing lens or mirrors, finally exit slit. So here depression element are sometimes we can use prisms or gratings. So based upon depressing element, so we have two different types of monochromators. One is prism type monochromator, the second one is a grating type monochromator. Then prism type monochromators. So just go to the picture. Here we have the series of components which I mentioned for the basic monochromators. There entrance slit should be there. Then after we have collimating lens, finally prism, then focusing lens, and finally slit. Okay, from the entrance slit, it allows a source of radiation to illuminate the first lens, which collimates the light, spreading it across the face of the prism. So when the light passes through the entrance slit, there should be a travel through collimating lens. So this lens is going to adjust the lens towards prism. The prism disperses radiation into the component wavelengths. So here we have some rotation. So by the rotation of the prism, so we should adjust the wavelength which we require. And the second lens focus on the spectrum at the focal plane. So that should be focusing lens. So from the focusing lens, the light passes the focal plane. So from the focal plane, so the entrance, that exit slit should be work, and this selects the band of radiation to reach the detectors through sample solution. The second one is grating type monochromators. So it is a device which consists of a series of parallel and closely spaced grooves rules on glass or any deflecting surfaces. So mostly in grating type of monochromators, we observe reflection or deflection, whereas in prism type, there we can observe only dispersion. Okay, then gratings are of two types. One is transmission gratings, then second one is reflection gratings. So just go through the picture. So the curved lines which are having in black color, so those act as gratings. Then we have some grooves. So by the help of grooves, we should separate the required wavelength from the polychromatic radiation. In UV gratings have 2000 to 6000 grooves per mm. Okay, this is second one is a grating type monochromators. It is a device which consists of series of parallel and closely spaced grooves. Rules on glass or any reflecting surfaces. So in the picture we have the black colored subject, so which having the curved lines. So this black subject is considered as a grating. So when the light passes through this grating, the radiation should be absorbed, which is unwanted. The required wavelength should be transmitted from this groups. Gratings are of two types. One is transmission grating, the second one is reflection gratings. In UV, gratings have 2000 to 6000 grooves per millimeter, whereas in IR, the gratings should be having less number, that is 10 to 100 meter grooves. And materials used for the constructions of gratings are quartz, sodium chloride and potassium bromide. So these three materials are highly inert to the IR radiation. So this is the figure for grating type monochromators, how the grating type monochromators are working inside the instrument. So here also we have entrance slit, so mirrors, we have 4 mirrors are there. So mirror 1, mirror 2, mirror 3. In first step, the entrance from the entrance slit, the light should be processed on collimating mirror M1. So after reaching M1, the sample radiation should be passed to the grating, where their transmissions takes place. From this transmission, so we should get the proper wavelength which we require. Then third one is sample handling in IR spectroscopy. For sampling techniques in IR depends on whether the sample is A. If it is gas, there we use gas cells for the handling. If it is liquid, we use thin films for the sample handling. Whereas if the sample is solid in nature, there we use potassium bromide disc, moulds and deposited films. For coming for gas sample, okay, so just go through the diagrams which are shared here. Okay, for this is the arrangement of the sample holder of gas. So infrared transparent windows allow the cells to be mounted directly. Internal mirrors are used which permit the beam to be reflected several times to the sample to increase the sensitivity. In vapor phase, the rotational changes in molecules occur freely and these low frequency processes can modulate the higher energy vibrational bands. Okay, first of all we have to fill the gas sample in the window which has transparent, and that should be allowed to for the determination using IR spectroscopy. Then liquid sample. So it consists of a sampling liquid as a thin film squeezed between two infrared transparent windows like sodium chloride flats. So here in the picture we have blue color and green. So these two blue color are act as a transparent windows of sodium chloride, where in the green color space, so we are going to place our sample which is in liquid. The salt plates or rock flats must be optically polished and cleaned immediately after use. Generally, toluene, chloroform are used to clean them. They should be dried and handled only by their edges. The thickness of the films can be adjusted by varying pressure used to squeeze the flats together. Generally, 0.01 to 0.1 millimeter thickness of the film be used for the determination. Then third one and final, solid sample. So when you are going to use solid sample, there we use three types of methods for this sampling. In that first one is KBr disc, okay, potassium bromide disc. It is prepared by grinding the sample with KBr and compressing the whole into the transparent water or disc. Just go through the two diagrams. So first diagram, which is a lid in which the KBr disc should be prepared. The second one is hydraulic press, we can say that one. By using hydraulic press, so we should use to press these lids disc to connect with the pressure gauge, and finally we get the thin sample disc of KBr. KBr means potassium bromide must be dried, hence grinding is carried out under infrared lamp to avoid condensation of atmospheric moisture, which gives rise to abroad absorptions. Grinding is done in a jet mortar pestle or commercially ball mills. Poorly ground mixtures lead to discs that scatter light than they transmit. Particle size of 2 micrometers must be achieved to be avoid scattering. So by using this method, we should get a thin films of or thin discs of potassium bromide along with the sample. The second technique of solid samples, that is a mold technique. So in this mold technique, the pastes are prepared by grinding the sample with a drop of oil, that is mold is squeezed between transparent windows as for liquid samples. Just go through the first two pictures. So there we are using nozzle. So is nozzle oil is used for the sample preparation. So that is comes under mold technique. So molding agent should be ideally be infrared transparent, but this is never true. The liquid paraffin, nothing but nozzle, is used to prepare nozzle molds, which is transparent over a wide range in IR spectrum. The third one is solid films. So in solid films can be deposited onto NaCl plates by allowing a solution and a volatile solvents to evaporate drop by drop on the surface of the flat. The polymers and various waxy or fatty materials often give excellent spectra in this way. So based upon the sample nature, we chose the different techniques. If it is solid, we use mold technique, KBr disc technique and solid films based upon the nature of the sample. So this is for today class. In next class, we are going to discuss the instrumentation of part 2. In that we discuss detectors and recorders and interpretation of IR spectrum. Thank you.